Hello everyone, this is Dr. Hopkins with our last video about buffers. Today we're going to discuss buffer capacity. So we're going to start out with the same buffer we've been making that we made 3 different times in the last video. We're going to use a pH 5 acetate buffer. We have our concentrations, and let's add 1 milliliter of 0.1 molar HCl to 10 milliliters of our 0.1 molar buffer, and check how the pH changes. So here we have our problem set up where we've got 10 milliliters of 0.0645 molar acetate and 0.0355 molar acetic acid. We're going to add 1 milliliters of 0.1 molar strong acid. So the strong acid is going to react with the base, not the acid. So our acetate reacts with H+. I've dropped the Cl. It's just a spectator ion, and we're going to generate acetic acid. So let's start with our moles, because these are, times 10 to the minus 4, and then we have 3.55 times 10 to the minus 4 moles of acetic acid, and then we have 1.0 times 10 to the minus 4 moles of H+ added. That's lower than the 6.45, so that's our limiting reactant. Okay, so minus 1.00 times 10 to the minus 4. We're left with 5.45 times 10 to the minus 4. We add 1 over here, and we get 4.55 times 10 to the minus 4. Now to determine the pH, we still have buffer because we still have acetate and acetic acid, so we're going to use the Henderson-Hasselbalch, which is 4.74 plus the log of the concentration of the base. Now, I'm going to do a shortcut here. I'm going to write 5.45 times 10 to the minus 4. Now, I could divide that by 11, or 0.011 liters, to get it to concentration. Or I could recognize that my 4.55 times 10 to the minus 4 is also going to be divided by the same number, so they'll divide out. And so we're left with this because they have the same volume. All right. And so that means if we solve this, we get a pH of 4.82, relatively constant. So we have, it's still a buffer at that concentration of acid. So now let's try this problem with the same buffer, 10 milliliters, pH 5 buffer, acetate. I didn't write that in, but that's what it is. Let's add a little bit more acid. So instead of 1 milliliter, let's add 10 milliliters of 0.1 molar HCl and see what that does to the pH. So now we've got the second problem set up where we have 10 milliliters of our buffer and 10 milliliters of a strong acid. And so we're the same thing. The acid's going to react with the base, not the acid. So I've set up the reaction, and we've got our acetate. The moles is 6.45 times 10 to the minus 4. That's a 4. 3.55 times 10 to the minus 4, of the acetic acid, and then we're adding 10 milliliters of 0.1 molar, so that's going to be 1.0 times 10 to the minus 3. So we multiply it by 10. That is no longer the limiting reactant, so we're going to have, this is all going to go away. And then this is going to subtract away this number of moles, 6.45 times 10 to the minus 4. And then we're going to add 6.45 times 10 to the minus 4. That's going to be 1.0 times 10 to the minus 3. This is going to be 3.55 times 10 to the minus 4. Now we have a weak acid and we have a strong acid. Strong acid wins. So our concentration of H+ is going to be 3.55 times 10 to the minus 4 divided by our total volume is now 20, so 0.02 liters. And we're left with 0.01775 molar is our concentration, and then our pH would be 1.75. So we take the negative log of that, and that's 1.75. Here we have, it's not a buffer, it's been overwhelmed, or we've gone beyond the buffer capacity for this buffer. So as you can see from our problem, once you add more moles of the acid to the buffer than there are moles of conjugate base, the buffer doesn't work. It doesn't hold the pH constant anymore. We've overwhelmed the buffer. We don't have enough of it to hold the constant or the pH relatively constant. The same would be true if we added moles of base. If we added more moles of base than we had moles of weak acid, the buffer will also no longer work. And so buffer capacity is just how much acid or base can be added before it won't be able to hold the pH relatively constant, or it won't be able to act like a buffer anymore. So our key takeaways here is basically buffers only work when we have conjugate base and weak acid and enough of it to be able to react away with whatever acid or base are added. The amounts or the number of moles of the acid and conjugate base is what dictates the buffer capacity, its ability to accept acid or base to it and still hold the pH constant. And because actually we're talking about buffers, but buffers are very practical. So if you know that you're going to end up adding more acid than your buffer can handle, just make a stronger or a higher concentration buffer. So until next time.